Hi everyone, it's Sir Capistrana again, and welcome back to our Chem 21 Organic Chemistry, wherein we will be actually talking about the last topic here in our organic chemistry. And for the last topic of in organic chemistry, we will be actually continuing our discussion regarding amino acids. And to be specific, we will be talking about peptides. So by peptides, peptides are actually just uh, you may consider this as a polymer of amino acids. By polymer, one of the examples of peptides is our glycine, ananyl, valyl, cysteine, serine. So as you may see here, we can actually see here that this peptide is actually made up of five amino acids, wherein we have here glycine, alanine, valine, cysteine, and serine. So in here, by peptides, yun nga, isa lang siyang mahabang chain or yung tinatawag nating polymer. And to be exact, when we say peptide, peptide is actually an amide produced by the reaction of alpha amino group of one amino acid and the alpha carboxyl group of another amino acid. So as you may see here, in this example, as you may have remembered, we have two parts of our peptides. By two parts of our peptides, we have here our amino group and we have here our carboxyl group. So once two alpha amino acids came in contact with each other, syempre hindi lang ganun ka-simple yung sinasabi natin yan. There's actually a biological concept behind this, but you will actually talk about those concepts under your biochemistry. But for organic chemistry, say we have a reaction of two amino acids, and those reaction actually occurs on our amino group, alpha amino group, and our carboxyl group here. So what will happen here is we will actually form an amide that is produced by this reaction. So in that, if we are to have a reaction of this two amino acids, I just written here the general structure of two amino acids. What will happen here is we will form a bond that will look like this. So, for example, if I just copy pasted this, what will happen here is we will have here a bond that will look like this. So let me just erase that. So, and we will have here a bond that will look like this. So we will retain our carboxyl group on our first amino acid. Then we will have here a bond towards the nitrogen of our next amino acid with its remaining nitrogen. So this green structure here is what we call uh, the amide. And this whole chain here, or this whole structure, is what we call our peptide. So the amide bond that links the amino acids together is what we call the peptide bond. So in that, yung peptide bond natin dyan, or peptide bond, is actually this amide structure. So this is our peptide bond, and the whole protein structure is what we call a peptide. So in that, we have there our formation of uh, peptide bond between two amino acids. So this is true for any alpha amino acids, but for other amino acids na hindi alpha, this can actually still occur. Magkakaroon lang tayo ng ibang structure. So in that, we have there the peptide and our peptide bond. So uh, peptide bonds are actually can be classified according to the number of amino acid residues that are present in the peptide. So what do we mean by that? So by the number of amino acid residues, for example, we have here our example presented earlier. We have here, we actually have here five amino acid residues. So, ano yung mga sinasabi nating 5 amino acid residues dyan? So, by that, we mean this one, this one, this one, and this one. So we have here 5 amino acid residues. And since we have here 5 amino acid residues, we actually can classify this glycyl, ananyl, valyl, cysteine, serine as pentapeptide. So by that peptide. So, bakit siya ulit tinawag na pentapeptide? As you may see here, since we have 5 amino acid, and when we say 5, that is actually penta. So, basically, if you have peptides that only have 2 amino acid residues, we can call that as dipeptide, tripeptide kapag tatlo, tetrapeptide kung apat, and the like. So, pero for peptides that weigh up to for peptides that weighs up to uh, 10,000 molecular weight. Okay? So, ito na mga tinatawag natin as polypeptides. So, ibig sabihin, ito yung mahaba na yung chains. So, by 10,000 molecular weight, as you may have remembered, carbon is just 12, oxygen is 16, and if you added all of the molecular weights of each atom, or the atomic weight of each atom, you will have here your molecular weight. So kapag umabot yun ng 10,000 or below 10,000, that is actually what we call polypeptides. So, pero kung halimbawa naman, if higher than that, we have there higher than 10,000 yung ating molecular weight, we can say that we have 50, more than 50 amino acid residues. We actually call this proteins. Okay? So, yun, doon natin maka-classify yung ating amino acids or yung peptide chain ng ating amino acid na protein kapag meron siyang more than 50 amino acid residues. So as you may see here, as you may think of it, kapag kumakain tayo ng ng baka or ng baboy, and we know that it contains protein, those protein actually has more than 50 amino acid residues. So as you may think of it, kaya kanyo consider nating uh, macronutrients ang ating proteins. So, dahil dun sa dami or sa taas ng molecular weight ng ating peptide chain mismo. So, that is how we classify our peptides. So, ulitin lang natin. So, kapag meron lang tayong kukunti pa lang yung amino acid residues dun sa ating peptide, kapag dalawa, we have their dipeptide, tatlo, tripeptide, and so on. So, if we have peptides that weighs up to 10,000 atomic mass units or molecular weight, we call them polypeptides. And we have there, if we have higher than 10,000 or we have there more than 50 amino acid residue, we call them proteins. Okay, so those are the classifications of our peptides. So when it comes to amino acid in the chain that has usually, sinusulat natin ito na depende dun sa kung paano yung structure niya. So, ano yung sinasabi kong para? Depende para dun sa structure niya. So, as you may see here, we have here our example earlier, our glycyl, alanil, valyl, cysteine, serine. So, paano natin siya papangalanan or paano natin siya isusulat ng ganito? Or bakit ganyan yung arrangement natin? So, usually, when we talk about peptides, uh, usually we in by convention we actually sequence the amino acid wherein we have the N terminal amino acids at the left, and we have the C terminal at the right. So ano ba yung sinasabi kong N terminal, C terminal? So as you may see here, we actually have here two free structures na nandun sa labas. Ibig sabihin by free, hindi sila nakabond sa iba pang carbon atoms or oxygen atoms. So as you may see here, we have this side and we have this side. As you may see here, we have here a free amino group and we have a free carboxyl group. So, paano natin kinakategorize to? This part is actually what we call this amino acid, yung tinatawag nating N-terminus side. So, and since this is N-terminus, ibig sabihin nitrogen terminus, ibig sabihin ang terminal natin ay nitrogen. Okay? And for this side, we actually call this amino acid as our C-terminus side. So bakit natin siya tinatawag na C-terminus? Because we have here our carbon. So by convention nga, ang N-terminus side ang nilalagay natin sa left at yung C-terminus side yung nilalagay natin sa right. This actually also help us regarding our naming of this peptide chain. So as you may see here, mag-start tayo ng naming dun sa ating N-terminus side, papunta ron sa ating C-terminus side. Kaya inuna natin yung glycyl or yung glycine natin kesa ron sa ating serine. So, baka nagtataka kayo, sir, paano po pinangalanan yan? So, basically, kung makikita nyo dito, we have here our glycine. We drop the INE, then pinalitan natin yun ng YL. So, also, we have here alanine. Ganun lang din ginawa natin. Dinrap natin yung, tanggalin natin yung INE and just replace it with YL. Then we have here our valine. Same concept. Remove the INE. Replace it with YL. Kaya siya naging YL. And also, same for our cysteine. Just remove our INE and replace it with YL. And for the C-terminus part, you just have to retain your serine. Kaya siya naging glycyl, anilyl, valyl, cysteal, serine. Okay. So baka mag-iisip din kayo, sir, wala pong mas maikling side or mas maikling way kung paano isusulat yan. So kung maaalala nyo, nung last time, during our discussion in the past video, we can actually abbreviate our glycine, or not the glycine, just our amino acids. So as you may have remembered, we can write glycine as gly. We can write alanine as ala. We can write valine as val. We can write cysteine as cis or cys. And we can also write our serine as ser or ser. So in that, we can actually write this name this way. So we can write it as gly dash. Next natin ay ala. So dash ala dash val dash cis dash ser. So we have here this polypeptide. This peptide. And as you may see here, kung isusulat natin siya using the abbreviation, we need to write it using dashes. And yun, hindi na natin kailangan isulat yung mga suffix natin like YL and yung ating IL. So that is how we can name our peptides. Pero for peptides na sobrang haba na, sobrang ano na, merong ibang way kung paano gawin yun, pero may encounter niyo yun later on during your biochemistry. So in that, let's go on to one of the organic related reactions of peptides. So parang actually kung iisipin nyo, ito ay kabaliktaran lang ng ating peptide formation. Pero ayun, bala mangyayari lang, we just need to remove or to remove the peptide bond. So para ma-release natin yung ating mga component amino acid or yung mga tinatawag nating amino acid residues. So paano ba nangyayari yun? So that actually happens through the process we call hydrolysis. Okay? But hindi ganito kasimple yung hydrolysis na nangyayari in nature. There's actually other mechanisms involved in hydrolysis wherein hydrolysis can be base catalyzed, it can be acid catalyzed, it can also be if I'm not mistaken, ay pwede rin siyang metal catalyze or using metals or metal replacement para makuha mo yung amino acid residues mo. But in any case, we just need to break this bond, this amino acid bond, or this peptide bond para makuha natin yun through hydrolysis, and by hydrolysis, that is just simply the addition of our water. But it's not simple like that, as that, pero let's just assume na ganito siya kasimple yun. So what will happen here is, due to the presence of water, we have here our OH and our hydrogen there. So what will happen is, sorry about that. Oh, no. Wait a second. So what will happen is, if we have this peptide bond, and this undergoes hydrolysis. Anyway, let me just remove this. Ayaw na lang ma-remove last. But then in any case, what will happen here is, due to the presence of our OH and hydrogen, we can actually break this peptide bond. And what will happen here is, you will have your, uh, let me just write this. So we will have here our alpha carbon there, bearing our R group. Nandito yung ating amino side. Nandito yung ating carbon kanina na nasa amide. And due to the presence of our OH, we will have here our OH plus yung side naman na to, wherein we have here this alpha carbon. We have here this amino group. Since NH lang siya kanina, dagdagan siya ng hydrogen, we will have here NH2. Then we have here this R group, this hydrogen, and we will have here this CO. So that will be the product of our hydrolysis. Pero ang sabi ko nga kanina, it is not as simple as that. There are actually other mechanisms that is involved for this hydrolysis. So kapag kasi hinayaan lang natin na na mag-undergo ng hydrolysis yung ating protein or yung ating peptides without any other catalyst, or yung hindi siya catalyzed yung reaction, matagal actually yung breaking. So, kumbaga, ang iniisip nyo, halimbawa, you have a dipeptide and that you want to isolate the glycine from another glycine. If you just add water, it can actually take half a day or 150 days to break that chain or to break that peptide bond. But in any case, that is the only organic chem related reactions of our peptides. So that actually ends the series, or our course here, or discussion for this course. This is the last discussion for our organic chemistry. So in that, uh, I expect you to have a clear mind, or to do great in this class. In that, thank you and have a great day ahead. Bye.